In this video, we are going to look at the problems in the chapter 12, section 1 slides. We're starting here. The 25 members of a psychology class were polled about the number of siblings in their individual families. Construct a frequency distribution for their responses shown here. So we start by setting a number here. This is the number that each student listed. We can call that X, and we've got a frequency, which we call F. And then our relative frequency, this is frequency distribution and a relative frequency distribution is what we're looking for. And that's X over F. Okay, so the values that we are given for X are 1, 2, 3, 4, 5, and 6. And I can just go along and count each one. So here's 1, 2, 3, 4 ones, 4 only children. And that should actually be F over N, not X over F. F over N, F is the frequency, and N is the total number of values, which is in this case 25. So we have 4 over 25, which is exactly 16%. For 2, 1, 2, 3, 4, 5, 6, 7. 7 over 25 is 28%. For 3, 1, 2, 3, 4, 5, 6. 6 over 25 is 24%. 4 appears 1, 2, 3 times. 4 over 25 is again 16%. And 5 appears 1, 2, 3 times. This is supposed to be 320 over 25, which is 12%. Okay, so this is again 3 over 25 and 12%. And finally for 6, 6 only appears once. 1 over 25 is 4%. And the important thing to check here is that this all adds up to 25. 4 plus 7 is 11, plus 6 is 17, plus 3. 4 plus 7 is 11, plus 6 is 17, plus 3 is 20, but this only adds up to 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26. I miscounted something, clearly. Let's see. 1, 2, 3, 4 ones. That's good. 7 threes. There should be 7 twos, 6 threes, yes. 3, 3. There should be 2 6s. I must have missed one of the 6s. There it is. There are 2 of them. That explains everything. So that's actually 8% there. All right, moving on. 40 students selected randomly in the school cafeteria one morning were asked to estimate the number of hours they had spent studying in the past week. Their responses are shown here. We are asked to tabulate a grouped frequency distribution and a grouped relative frequency distribution, which we'll do in the same table, and then construct a histogram and a frequency polygon for the given data. So for our groups, we'll set up our class limits. It's up so that we've got just the numbers visible there. 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. We do a tally. So we go one by one and see which of these groups each number falls into. 18 is in 10 to 19, 60, 72, 58, 33, 15, 12, 36, 16, 29, 26, 41, 45, 25, 32, 24, 22, 55, 30, 31, 55, 39, 29, 44, 29, 14, 36, 31, 45, 62, 36, 52, 57, 38, 36, 23, 33, 44, 17, 24. Now we add all of these up to get our frequencies. There are 6 between 10 and 19. There are 9 between 20 and 29, 12 between 30 and 39, 5 between 40 and 49, 5 between 50 and 59, 2 between 60 and 69, and 1 between 70 and 79. And then we calculate our relative frequencies. Remembering that there are 40 total values here. This is 6 over 40, which is 15%. 9 over 40, which is 22.5%. 12 over 40 gives us 30%. 5 over 40 is 12.5%. Same here. Two over 40 is 5%, and 1 over 40 is 2.5%. Now we want to translate this information into a histogram and a frequency polygon. So first we'll start with our histogram. And we'll just take, let's see, we've got so we've got 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and 70 to 79. Okay, and we can do sets of 2. We're not going to need to go above 12. And remember that our columns should be adjacent here. So we'll start this first one. It's got a height of 6. Our next column has a height of 9. They should be uniformly wide, but since I'm doing this by hand, we're not going to worry about that too much. This next one has a height of 12. And then 5. And then 5 again. And 2. And 1. There is our histogram. And then for our frequency polygon, we can just take the center points of the top of each of these columns and connect them. You bring that down to the ground there. Not quite straight enough there, but whatever. And there we go. There's our frequency polygon that goes along with it. Present the study timed data from the previous problem as a stem and leaf display. Okay, so our stems are going to be 1, 2, 3, 4, 5, 6, 7. We don't need anything else. And then our leaves will just be the digits that appear. And often we want to put these in order, but we're not going to worry about that for this particular problem. If you were to do this for something in MyLabs, you might want to put them in order. It might ask you to put them in order. And importantly, this is something that my stats students have run into a lot. I sometimes use commas when I'm doing this. Don't use commas. They don't want commas in MyLabs. Okay, so here is 18, so we'll put an 8 here. We've got a 60, so we put a 0 in the 6th row. 72, we put a 2 in the 7th row. 58, put that there. 33, 15, 12, 36, 16, 29, 26, 41, 45, 25, 32, 24, 22, 55, 30, 31, 55, 39, 29, 44, 29, 14, 36, 31, 45, 62, 36, 52, 47, 38, 36, 23, 33, 44, 17, and 24. That's it. There is our stem and leaf display. That's it for this video. If you have any further questions, get in touch.